we're given an angle alpha, we're given an angle beta, okay, described in the ratio form. So we need to make sure that we have a picture for those. So I'm going to draw alpha, okay, and it's in quadrant 2. It says that it's negative 3/7. So using Pythagoras, I'm going to get root 40 here. I also have an angle beta. They give me the beta in quadrant 4. So I'm going to draw beta in quadrant 4. Okay, and beta is negative 4/5. I'm just going to draw it like that. So that's negative 4/5. Using Pythagoras, I get positive 3 since it's in quadrant 4. So it asks you to give an exact value expression for sine 2 alpha. So we're going to take that alpha picture and we're going to use the formula for that. Okay, so sine 2 alpha is equal to 2 sine alpha cosine alpha. And we're just going to take that single angle. So we don't have a picture for the double angle here. So we're just going to take that single angle alpha picture and the identity and generate an equivalent expression. So sine of alpha is going to be root 40/7. Cosine is going to be negative 3/7. So we end up with negative 6 root 40/49. Okay, so that's the exact value for that double angle. So we don't have a picture for that double angle, but if we can imagine where that would be somewhere in quadrant 3. We get a negative sine value. That looks about right. So we take a look at cosine of, the next one's cosine of 3 beta. Now we don't have a 3 beta formula, and so we need to make sure that we put this into an identity. So how are we going to do this identity? So one thing that you don't want to do is you don't want to do this. So cosine of 2 beta, we'll just times that by 1.5. Okay, this is a ratio piece. We're trying to change the multiplier on the angle. That doesn't work. They are incompatible. This does not work. So what we have to do is we have to think of an identity. Well, for cosine 3 beta, with identities, the only way I can get that is to do this. Cosine of 2 beta plus beta. Okay, that's 3 beta. Well, here I have a cosine sum and a double angle here. So we have to apply this double angle, the sum identity, with the double angle. So we have to make sure we have a way to do that. Okay, so what am I going to apply first? Well, I need to apply the plus identity, and then I'm going to embed it in that plus identity. I need to have a double angle embedded in it. So I'm going to start with the sum identity. So it's going to be cos minus sine. Okay, so I have a picture for my single angle beta. There it is. I didn't draw the beta in there. And I have to then, I don't have a picture for the double angle beta, so I can't use any of these ratios. So I'm just going to plug in for now the single angle ratios. So cosine beta from the picture looks like 3/5. And the sine of beta, again, I can't do 2 beta, but I can do 1 beta. The sine is negative 4/5. So I'm just going to plug that in. Okay, well, I still need to find a ratio for 2 beta. I don't have a picture for 2 beta, so what I'm going to have to do is I'm going to have to apply a formula for that one. So I'm going to use the cosine formula, which is, and I can have choice of any one of those 3, but I'm just going to use sine cos squared minus sine squared. And I'm just going to put in there my 3/5 minus my double angle formula for 2 beta. Again, I go back to my formula sheet and I do my 2 beta. And I'm going to write in my negative 4/5 just to make sure that I keep track of that. So once I have that, now I have everything in terms of a single angle beta, I can go back to my picture and I can replace the cos beta sine beta with the equivalents for that single angle beta here. So I end up with cosine of beta was, it looked like it was 5 over 3, or sorry, 3 over 5 squared. Sine of beta is negative 4 over 5 squared, times 3 over 5 minus 2 times sine beta cos beta. So we end up with multiplying that by negative 4 over 5, and we'll work that all out. So when I calculate that all out, I'm going to end up with negative 7 times 3 is negative 21 over 125 minus, that's 3 negatives, so I'm going to have negative. It's going to be 2 times 12 times 4 is 96 over 125. Again, notice I get a common denominator. When I subtract those, I'm going to end up with negative 117 over 125. So there's my cosine ratio of 3 beta.